Properties of AC supply. Power supply. All electronic circuits need a power source to work. For electronic circuits made of transistors and or ICs, this power source must be a DC voltage of a specific value. A battery is a common DC voltage source for some types of electronic equipment, especially portable like cell phones and iPods. Most non-portable equipment uses power supplies that operate from the AC power line but produces one or more DC outputs. Power supply characteristics. The input is the 120 volt 60 Hz AC power line. Alternatively, the input may be 240 volts AC. The power supply converts the AC into DC and provides one or more DC output voltages. Some modern electronic circuits need two or more different voltages. Common voltages are 48, 24, 15, 12, 9, 5, 3.3, 2.5, 1.8, 1.5, 1.2, and 1 volts. The good example of a modern power supply is one inside a PC that furnishes 12, 5, 3.3, and 1.2 volt. The beside given is the power supply system coming from. This is a transformer, and this is the AC line, which the current comes from the AC supply and converts into step down to 12 volts, 5 volts, 3.3 volts, and this is the earthing system. Components of a power supply. Main circuit in power supplies: AC line filter, transformer, rectifier, transformer, which transform the AC to DC, rectify both works on that, and filters them. A regulator which regulates the voltages, which is available in the uh, electric appliances like AC, fan, TV, fridge, etc., etc., and the regulator to the load and DC to DC converter. Power supply. The AC line is first passed through the low pass filter of the form. This eliminates noise on the AC line from bothering the power supply circuits and prevents unwanted signals from the power supply from being transferred back into the AC line where they might interfere with other equipments. This means when the AC power is transferred from the main supply to the home appliances, a low pass filter is between the AC supply and the equipment, which reduces the noise, which may help in which prevents the appliances to from getting damaged. Transformer. A transformer is commonly used to step the input AC voltage level down or up. Most electronic Most electronic circuits operate from voltage lower than the AC line voltage, so the transformer normally steps the voltage down by its turns ratio to a desired lower level, which means N1 is greater than N2. For example, a transformer with a turns ratio of 10:1 would convert the 120 volt 60 Hz input sine wave into a 10 volt sine wave, in which the rectifier also plays a main role. Rectifier The rectifier converts the AC sine wave AC sine wave into a pulsating DC wave. There are several forms of rectifiers used, but all are made up of diodes. Rectifier diodes means semiconductor diodes like AND, OR, XOR, etc. etc. Rectifier types and operation will be covered later. Rectifier produces a filter. Rectifier produces a DC output, but it is pulsating rather a constant steady value over time like that from a battery. A filter is used to remove the pulsations and create a constant output. The most common filter is a large capacitor. The regular, the regular is a circuit that helps to regulator. The regulator is a circuit that helps maintain a fixed or constant output voltage. Changes in the load or the AC line voltage will cause the output voltage to vary. Most electronic circuits cannot withstand the variation since they are designed to work properly with a fixed voltage. The regulator fixes the output voltage to the desired level when then maintains that value despite any output or input variations. DC to DC converter. Most modern power supplies also contain one or more DC-DC converter. Modern electronics often demand different voltage functions. A DC to DC converter changes one DC voltage to another higher or lower DC voltage. A DC to DC converter is used with a power supply to prevent the need for a second AC-DC supply. How a rectifier works. The simplified form of rectifier is a half-wave rectifier shown here. Only the transformer, rectifier, diode, and load are shown without the filter and other components. The half-wave rectifier produces one pulse for each cycle of the input sine wave. When the sine wave goes positive, the anodes of the diode goes positive, causing the diode to be forward biased. The diode conducts and acts like a closed switch, letting the positive pulse of the sine wave to appear across the load resistance. How a rectifier works continuation of the previous slide. When the sine wave goes negative, the diode anode will be negative, so the diode will be reverse biased and no current will flow. No negative voltage will appear across the load. The load voltage will be zero during the time of the negative half cycle. See the waveform that shows the positive pulses across the load. These pulses need to be converted to a DC constant. Bridge rectifier. Another widely used rectifier is the bridge rectifier. It has four diodes. This is called a full wave rectifier as it produces an output pulse for each half cycle of the input sine wave. On the positive half cycle of the input sine wave, diodes D1 and D2 are forward biased, so act as closed switches appearing in series with the load. On the negative half cycle, diode D1 and D2 are reverse biased and diodes D3 and D4 are forward biased. So current flows through the load in the same direction. How the filter works. A large capacitor is connected across the load resistance. The capacitor filters the pulses into a more constant DC current. When the diode conducts, the capacitor charges up to the peak of the sine wave. Then when the sine voltage drops, the charge on the capacitor remains. Since the capacitor is large, it forms a long-time constant with the load resistor. The capacitor slowly discharges into the load, maintaining a more constant output. The next positive pulse comes along, recharging the capacitor, and the process continues. Ripple. Ripple. The capacitor does a good job of smoothing the pulses from the rectifier into a more constant DC wave. A small variation occurs in the DC because the capacitor discharges a small amount between the positive and negative pulses. Then it recharges. This variation is called ripple. The ripple can be reduced further by making the capacitor larger. The ripple appears to be sawtooth shaped AC variation riding on the DC output. A small amount of ripple can be tolerated in some circuits, but the lower the better overall. Regulators. Most regulators are ICs. These are feedback control circuits that actually monitor the output voltage to detect variations. If the output varies for whatever reason, the regulator circuit automatically adjusts the output back to the set value. Regulator holds the output to the desired value. Since ripple represents the change in the output, the regulator also compensates for these variations, producing a near constant DC output. In summary, all electronic circuits and equipment need a power supply, usually one that supplies a very specific DC voltage. A battery is a near perfect DC supply, but it is used mainly in portable applications. Most equipment uses an AC to DC power supply. In most AC to DC supplies, the 120-volt AC line is first filtered, then step up or down to the desired voltage level, then rectified into pulsating DC, then filtered to a constant DC. A regulator holds the voltage to a desired level. A DC to DC converter may also be used to generate another DC voltage. The first two most common rectifiers are the single diode half wave rectifier and the four diode full wave rectifier. Thank you.